we want to start with Kubernetes. Kubernetes is an open source platform. It is also known as K8S. K being the first letter of the word Kubernetes, and S being the last. Now, there are 10 letters in all. So we have 8 letters between K and S. So we have K8S. So Kubernetes. Now, Kubernetes is a container orchestration tool, right? A container orchestration tool that we can use for deploying containerized applications, automating the deployment, scaling, and managing those containerized applications. Now, we can look at the benefits of Kubernetes. But before then, I want us to look at this website, very interesting website, to see in details what Kubernetes has got to offer. Kubernetes.io. Okay, that is it. So here we see Kubernetes defined. Okay, now we also see some of the benefits of Kubernetes, right? We see that it can scale without increasing your operations team. So you can increase your scale of operations without increasing your manpower requirements. That's the power of Kubernetes. Then, never outgrow. What's this saying? Okay, Kubernetes has this flexibility that grows with you to deliver your applications consistently and easily, no matter how complex your needs are. Okay, and also looking at this, you can run Kubernetes from anywhere, whether on premises, whether it's hybrid, or the public cloud infrastructure. So wherever it is, you can run Kubernetes. Now, what are the features of Kubernetes, right? Let's take a look at some of them. You see automated rollouts and rollbacks, okay? So this is a very important feature of Kubernetes. So with Kubernetes, if something goes wrong, Kubernetes will roll back the change for you. Okay, so this is a very strong feature of Kubernetes. So Kubernetes also performs the function of load balancing. Okay, Kubernetes gives pods their own IP address and a single DNS for a set of pods and can load balance across them. You can see this is another very interesting feature of Kubernetes, right? So also for storage orchestration, okay? So it automatically mounts the storage system of your choice, okay? Whether from local or from public cloud provider. Maybe it's GCP or AWS, right? So that's interesting. So it also does secret and configuration management. We'll be seeing more of this as we proceed with this course. So secret and configuration management. So that's another very important thing Kubernetes does, right? So you can keep your secret details like your password, your token, username, all those secrets can be kept in a configuration file, okay? So you can also see this. It automatically places containers based on their resource requirements. So it's automated. So containers are placed based on their requirements and constraints while not sacrificing on availability. Remember, load balancing, okay? So also we can look at batch execution. So Kubernetes can manage your batch and CI workloads, replacing containers that fail if desired. So when the container fails, Kubernetes replaces it, okay? So That's another important feature. So also with allocation of IPv4 and IPv6 addresses to pods and services, that's another interesting feature, right, that Kubernetes has. It also does horizontal scaling, scales your application up and down with simple command or automatically based on CPU usage. It is also self-healing. When a container fails, right? When a container fails, it is replaced, right? It reschedules container. When it dies, it kills a container that does not respond to your defined health check. Okay, so these are key things. You see self-healing. So restarts containers that fail, replaces and reschedules containers when nodes die, right? Kills containers that don't respond to your user-defined health check. So also, finally, you see, designed for extensibility, right? So this is also very interesting. So now, let's look at some keywords that I've been able to pick out of this Kubernetes.io. Very interesting website. So they're able to pick out some keywords. They're able to pick out some keywords. I've seen nodes, right? I've seen node. I've seen cluster. I've seen control plane, right? I've seen worker nodes. I've seen pods, seen secret. So let's look at each of these, right? Let's look at each of these and see what Kubernetes.io, how each of them is explained, right? So let's pick them one after the other. So let's take this, for example. Let's go to documentation. There's a lot we can see here. Let's search documentation for node. Okay, we'll see nodes, right? Kubernetes runs your workload by placing containers into pods to run on nodes. Okay, so let's relax and look at this, right? We are familiar with container from our previous class in Docker. We've seen containers, right? Pods, maybe not, and nodes, maybe not. Now, let's look at it one after the other. So let's go further. A node may be a virtual or physical machine depending on the cluster. Okay, now we've seen what a node is. We've launched EC2 instances. So from what I read here, I see that an EC2 instance is an example of a node, okay? So, and on top of these nodes, there are pods that run on those nodes. And inside these pods, containers are placed, okay? So, and if we go further, we'll see something. Each node is managed by the control plane and contains the services necessary to run pods. Each node is managed by the control plane and contains the services necessary to run pods. Okay, we've seen cluster, right? Very interesting. We've seen cluster. Okay, now let's look at the keywords I listed here. Cluster, control plane, nodes, pods. So 1 to 5, we've seen all of them while looking at just node. Okay, so I want us to look at this link, right? Let's take a look at this link. So before then, we see a cluster comprises the control plane and the worker nodes. So the control plane is the manager node, right? And the worker nodes are the nodes that execute, right? So now let's take a look at this link to understand what a cluster really means, okay? So then we'll take a look at all those points, pods and nodes and cluster. So let's take a look at this link to have a better view of what we are talking about. Okay, so let me check it out. So looking at this, we look at Kubernetes components, okay? Kubernetes component. So taking a look at this, we see we have the Kubernetes cluster, right? So the cluster has the control plane. So this control plane is the manager node, right? And you see these other guys, these are the worker nodes, okay? Look at this, these are the worker nodes. So the control plane, if you look at the composition, it has the controller manager, right? It's defined here. Look at it, the full CM, controller manager. This one is cloud controller manager. And we have the API here, right? We have the etcd, right? The etcd. This is like the storage, right, of the control plane, okay? And we have the scheduler here. This is the scheduler. So these are the components of the control plane. That's the manager node, okay? Now, these are the worker nodes, right? The worker nodes comprises the kubelet and the kproxy, okay? So for each of these, they are defined down here, okay? The API server is a component of the control plane that exposes the Kubernetes API. The API is the front end for Kubernetes control plane, okay? So that is the API, right? It exposes the control plane, is the front end. Can you see? It interacts with the nodes, okay? Now, let's look at the next one, etcd, consistent and highly available key value store used as Kubernetes backing store for all cluster data. This is like the brain, is the storage for the control plane, okay? So we have the scheduler, Kube scheduler. Okay, control plane component that watches for newly created pods with no assigned node and selects the node for them to run on. So it assigns tasks, right? So that's what the scheduler does. It schedules tasks for the new nodes, right? So let's look at the control manager. So this one runs the controller processes, right? Each controller is a separate process, but to reduce complexity, they are compiled into single binary and run in a single process, okay? So that's what the controller manager does. So these are some types of these controllers: node controller, job controller, endpoint controller, and service and token controller. Okay, we'll be getting to understand this more as we go into details, right? So now let's look at this. This is the cloud controller manager, right? Let's look at it from the diagram. This is CCM, you can see, interacting with the cloud provider API. Okay, now let's look at what we've got here to say. This is a component that embeds cloud-specific control logic. The cloud controller manager lets you link your cluster into the cloud cloud provider's API, and separates out the components that interact with the cloud from the components that only interact with your cluster, okay? So that is the cloud controller manager for you. So you can get to read more from here, right? Just to sharpen your understanding, right, about the components. Now, looking at the node, right? Let's look at the components of the node, right? There's the kubelet, okay? The kubelet is the agent that runs each node in the cluster. It makes sure that the containers are running in a pod. Okay, now this is the kube proxy. It's a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. Okay, we'll get to learn more about service. Okay, now container runtime. Container runtime is a software that is responsible for running containers. Okay, so just a lot to read. So this is plenty of resources you can get from Kubernetes.io. Okay, so we won't dwell so much on that. Let's go back to the notes we took. We've seen what controller plane is, right? That is the manager node, right? And we have the worker nodes, right? Which we have in the diagram here. Let's take a look at it again. This is the controller node, which we've seen the components. Control plane, that's the manager node. And these are the nodes, right? Which we can also call the manager nodes. There's worker nodes, sorry about that. So these are the worker nodes, and we've seen the components. So on each of these worker nodes, there is a pod, right? The pod is like an abstraction, actually, but the pod is like a combination of one or more container. That is what a pod is. Okay, combination of one or more containers, right? Just as we can say, just a minute, let me just confirm this. We can say let me just confirm this. You can say a herd of cattle, right? You can say a herd of sheep, right? So this is, we can say, a pod of containers, okay? Just as we can say, we can relate this, a herd of cattle, right? Let me bring that up. Just as we can use this expression. Let's bring this up. Is this bold enough? Okay. Let's broaden this. Let's broaden this. Okay. So just as we can say a herd of cattle, right? Can say a herd of sheep. So also we can say a pod of containers, right? It's like an abstraction, but it is what it is, right? So let's see what Kubernetes.io has to say about that. So let's see Kubernetes.io. Okay, let's search for pods. Okay. Okay, so a pod, okay, oh yeah, is a group of one or more containers, right? With shared storage and network resources, and a specification for how to run containers. Okay, so a group of one or more containers is a pod, right? A group of one or more containers, you can say it's a pod, right? And we all know what containers are. Okay, now, and also for what we see here, okay, so let's just proceed. We'll get to see more as we continue. So now, secret, okay, let's look at what secret is. Secret. So let's see what secrets are. Okay, secret. So a secret is an object that contains a small number of sensitive data, such as password, a token, or a key. Such information might otherwise be put in a spot specification or in a container image. Using a secret means that you don't need to include confidential data in your application code. Okay, so secrets are similar to config maps, but are specifically intended to hold confidential data. So now we've seen secrets, right? We use secrets to hold confidential data like password, token, right? So if we need to configure a secret, we can always come here to edit the object below, right? To configure a secret, just copy and paste, right? And edit to our specification, right? So this is a secret. So you can see we have username, we have password. It could be username, it could be token, it could be key, right? So this is a secret for you, right? And we can also see how secrets can be used down here. Okay, so this on that. So let's proceed to looking at what we have next. Okay, we also see, before we see service, let's look at config map because it was mentioned earlier. So the config map is similar to secrets, except that config maps are used to hold non-confidential data. Okay, while secrets are for confidential data, you can say config maps are used to store, you can see, let's see what we have here. Used to store non-confidential data in key value pairs, okay? Such as environmental variables, command line arguments, and all of that, right? For example, if we want to run, let's see this. Let me just show you something. So this, for example, is an example, right? Look at a config map, okay? Can see a config map. So all we need to do, copy and modify, right? So we have sample templates we could use here, right? So that's config map for you, okay? So as we proceed, we'll get to see more. Okay, we're supposed to look at service, right? Service. So let's take a look at service. Service, it's got to do with networking, right? Okay, so let's look at service. Service is an abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name so that loads can be balanced across them. Okay, look at an example of service. You can see the configuration file, service, you can see. So to create a service, all you need to copy this, paste it somewhere, and modify accordingly. Interesting, right? So what else can we look at? Let's look at, we've seen config map. Let's look at volumes, right? Volumes has to do with storage, right? Volumes have to do with storage. So let's take a look at what Kubernetes has got to say about that. So volumes. So with volumes, let's see. Okay, we all know that files in a container are ephemeral. What it means is that when a container dies or is restarted, the content is gone, wiped out, right? So a second problem that occurs when sharing files between containers running together in a pod. Okay, so one problem is the loss of file. Okay, so secondly, when the kubelet restarts, it restarts with a clean state, right? So which is another problem. So with Kubernetes, this problem is solved, right? So Kubernetes has the volume concept, right? So with Kubernetes, you can take a look at this, right? So this is a configuration file, right? For this configuration file for EBS, right? So this is another configuration file down here for Cinder volume. You can explore, right? When the time comes that we need to use some of these configuration files, we now know where to get them from, right? So then we can modify accordingly. Okay, now what else can we look at? Let's look at deployment, right? Deployment, okay? We look at deployment. Let's take a look at deployment. Let's take a look at deployment. Deployment, okay. Deployment. Let's take a look at deployment. Let's take a look at deployment. Okay. Okay, deployments. Okay, so deployments provide declarative updates for pods and replica sets. We've looked at pods, so we get to see replica sets, right? Trying to tell us the number of pods, right? You can see this is an example of creation of a deployment, right? So when creating a deployment, you can say, oh, this deployment. For example, let's take a look at something, right? Let's take a look at, let's say this is the script I want to use for installing my Kubernetes. Okay, now take a look at this, right? This is a deployment, right? You can see this is a deployment, right? So instead of running deployments like this, we can have them in this format, right? Where is it? In this format. We can have them in this format, right? So that we say, oh, this deployment, name Nginx deployment. In that case, maybe one, the app is Nginx, container port 80. You can see all those things that we set right there. We can actually set them up in this file, right? So in that case, when running the file, instead of saying kubectl run and specifying all of this long stuff, all we need to do is to say kubectl apply, then we specify the name of the file, right? Which is simple, right? And straightforward. So that's what we can use this for, and we can create as many replicas as we want, right? So that's a deployment for you, okay? So we'll get to see more of this as we proceed, right? You can see kubectl apply, then specify file name, right? And all of that. So it could be very interesting, but let's go on as we've just started, right? So let's look at the next. Okay, stateful set. Okay, so let's copy stateful set. Stateful set has to do with similar to deployment, but for stateful set is a workload API object used to manage stateful applications. So stateful applications are applications that can store, whereas stateless applications are applications that can't store, right? So with stateful applications, we are emphasizing on applications that can store, right? So storage is something we'll need to emphasize on. Okay. For example, looking at this, you can see this part has to do with service. You can see service. So when you see this dash dash dash, right, in a configuration file, it means it ends here. This part, this is the end for this part, and something else begins here, right? So you can see API version 1, kind service, you see, it ends here, dash, dash, dash. And this is something else that starts here. So the stateful set is covered here, okay? You can see storage, you can see 1 gig, right? So storage class, right? You see, because stateful set deals with stateful applications, right? So for this, we are talking about storage, right? You see storage is a component, whereas when you look at here, do you see storage? No. So this component is the stateful set, okay? So let's, now that we've covered all of this, we'll get to cover them more as we proceed, but let's dive into action, right? Let's see what we can get out of. So we want to start up some servers, Kubernetes server. So for the purpose of this session, I'll be launching 2 servers. I'll be launching 1 manager. Okay, I could launch 2, but you could also launch 1 if you want, right? But for the purpose of this session, I'll launch 3 servers, 1 manager, and 2 workers, okay? So the manager, as you remember, is the control plane, right? And the worker nodes are the nodes, right? From what we saw in the cluster earlier, right? In the cluster, remember what we saw in the cluster? Okay, let's see the cluster. Let's see. Okay, so in the cluster, you see the control plane. This is the manager node. And for our sake, in this session, we'll be launching 2 worker nodes, right? And we'll be connecting them, right? So we'll be using a script, but as usual, I'll be going through the script before we run the script, so we'll see what we are actually doing. So let's start by launching the instances, but before then, okay, let's see if we can just walk through the script so we can have a better understanding of what we are doing. So this script will help us set up Kubernetes using kubeadm in AWS EC2 Ubuntu servers. So you will need a minimum of, we'll need a minimum of 3 servers, maybe 2. When you are working on your own, you could work with 2. The manager will require a T2 medium. The workers will require a minimum of 2 gig RAM. So I'll be using T2 small for the workers. So we need to open certain ports, right? There are certain ports that are required. But for the purpose of this exercise, because we need to open like 5 or 6 ports for the manager, then 2 for the workers. So, but for the purpose of this exercise, we'll open all traffic to make it simple, right? Then as time goes on, as we get to understand the costs, then we can now specifically open the specific ports required, right? So, but what matters now is understanding the cost, okay? So now that we are on that, so what else do we need to do? So on each of the server, right, on the manager node and the worker nodes, we need to install all of this, right? We'll install all of this using a script. Then once we get here, okay, so 1 minute. Okay, once we get to this point, from the top up to this point, that's from the top up to this point, are for all the servers, okay? From up here to line 60, okay, line 64, right? So for this, although you'll be able to run the script, just copying because I've commented this out. From here, you can see multi-line comments, right? So it wouldn't disturb, right? So this one will only apply to the manager node, right? After installing on the worker nodes and all of that. So we install this particularly to the manager node, right? Then we'll look at some of these steps, right? They are commented out as well. So just for some guidance, so we can run few commands before we end the session, right? So let's get cracking. Okay, so we want to start by launching the manager node. Okay, so let's launch an instance. I want to start by launching the manager node, right? That's the manager node, right? Kubernetes manager node. So I want to launch an Ubuntu server. So for the manager node, I want a T2 medium for the manager node. So I want a T2 medium, okay? T2 medium for the manager node. So I want to use an existing key pair. Okay, so I'll proceed to creating a new security group. Let me create this security group and call it and open all traffic. Let's see, let's open all traffic. Let's open all traffic. Let's open all traffic. All traffic. Open from anywhere. Okay. So this is what I want to do. For the manager node, I just need one instance. So I launch one instance. Okay. T2 medium, that's fine. So let me select let me select 20.04. Okay. Confirm changes. Okay. 20.04. Let me confirm that the security group is still okay. The security group has been reset. So let me change it back. Create security group. New. Let me open all ports. Okay. Open all traffic. So what I've done there, let's take a look at this. What I've done here is just to change this to Ubuntu Server 20.04. Okay. So that's all I changed there. So, and I want to make sure all traffic are opened here. So let me give this a name. Let me call it my Kubernetes. Let me call it let me call it Kubernetes security group. It is SG security group. That's Kubernetes security group. So all traffic opened, right? So Ubuntu, and it's T2 medium, okay? So that's all. So let's launch the instance. I just want one instance of this. So I've launched the instance. So let me launch the two other instances using T2 small. Launch instance. Launch instance. Let me launch. Let me call this worker nodes. Let me just call it worker node. I'll rename them accordingly. Ubuntu as well. Let me be consistent. 20.04. Okay. I also want to scroll to use T2 small. I need 2 gig memory. Okay. T2 small. So I want to use the existing security group that I created just now. I called it Kubernetes security group. Kubernetes SG. This is one. So I want to scroll down to launch 2 instances, T2 small, launching 2 instances. So let's launch 2 instances. Let's decide it. Did I get it? Oh, keep it. Ademola, I missed that. Okay, so let's launch T2 small, 2 instances, same security group. Okay, so now let's check out our instances and set them up on mobile X10. Okay, so this is my mobile X10. Okay, so I want to check this. Let's see the instances running. So this is a manager node. Okay, so I copy that. That's a manager node. I come in here, right? I want to start a new session. That's the manager node. Specify username. So the default is Ubuntu. Okay, so I come in here. I use private key and I select my private key. Ademola, yeah. Okay, so this is good. Okay, so that's clear. So we are in here. Okay, now let's look at the other servers and okay, let's rename this. Like to rename, let's call this master node. Let's call this the master node. Right, that's a master. Manager node was what we called it. Manager. Okay, so this is the manager node. So let's see whether the others are up as well. Rename them and dashboard running. So we have these other ones running too. Let's call this worker node 1. Worker node 1. Okay, let's call this one worker node 2. Okay, so worker node 1 and worker node 2. So we open this up. Let's see what we have. That's worker node 1, right? Worker node, is that one? Yeah. So let's go to mobile X10 to set that up as well. Sessions, new session, SSH, specify username Ubuntu. true, right? Then we select private key. That is it. So worker node, let's rename this, call this worker one. That's worker one. Okay, so we have worker one. Okay, so what on there? So that's worker one. Okay, so let's check out worker two. Worker two. So let's see worker two. The IP addresses look similar. Let me just be sure that it's not the same thing. Okay, they are different. This one ends in 83. Okay, so worker two. Okay, so I want to specify username, that's Ubuntu. And I want to use private key, right? That's adora.pem. So expand and clear. So let's rename this and call it worker two. Let's call this worker two. So that's worker two. So we have them up here, so we can start. Let's start with the manager node. Remember, as we said, we have a script that we can run all through, right? So we've commented out those components that have to do with the components that relate to that's the manager node. Okay, so this is the script, it has everything. So we just copy and install across. Then we'll go specifically to the manager node to install. So we don't want to install line by line. It's going to waste our time. So let's just use a script. We've gone through the script to understand the components, right? I'll share the script, right, as part of the installation script. It's already there, so you can check it out. Part of our installation script. So you can study it and you get it in detail. So I've copied the script. Okay, so let's get column WQ. Okay, so I can run this sh install. So let this run. So let me go to the next one. Vi install.sh. So let me paste this. SQ column WQ. So sh install.sh. So let's go to the worker node drill and do the same thing. So this is prompting us to, okay, any action required? I don't see any. So vi into install.sh, right? Then let's paste this here. SQ column WQ. So sh install.sh. So let's see what we have here. So this is done. So what else do we need to do? Let's look at this. This is still going on. Okay, this is fine as well. So let's see what we have here. Okay. Anyway, you might see this, right? Please disregard this. I've tested the script, it works, right? So as we can see, as we proceed, we'll see that everything will work well. So I even installed the script line by line. I didn't see any error. But nevertheless, we'll continue with this and it will serve our purpose. Now, we've seen this worker node 1, worker node 2, right? So everything is done. So that's fine. So let's look at manager node, right? This is the one we need to do extra work on, right? So let's pick up our script and see what else is required of us. So let's scroll down. Okay, let's scroll down. So this is where this one starts, right? The multi-line comments, right? This will only apply to the manager node. It starts here and ends here. So all of this did not run, right, up to the end because they are all commented. But these ones here that are highlighted relate specifically to the manager node. Okay, so what we are going to do is that we are going to pick this one after the other and run them on the manager node. So where's our manager node? This is our manager node. Okay, so manager node. What have I copied? Let's copy it again. So this is our manager node. I copied this, copy. Okay, so that's the manager node. Come here, right? Am I sure? Manager node, yes, it is. So I paste this, right? I want to pull images, right? So I'm pulling images. So what else should we do? Right? So I want to come here to initialize Cube ADM, right? And this network specifically relates to the network for the, what's it called? The container runtime that we chose, okay? That's container D. So we copy this, okay? We want to initialize Kubernetes in the manager node, right? So we copy that. So let's come here to the manager node, right? That's done. We paste this, we run, okay? Okay. This can take up to, so let's just wait for it a bit. Okay, so it's done. You can see your Kubernetes control plane, right? The manager node has initialized successfully. To start using the cluster, you need to run the following as regular user. Remember, the commands we've run before, we ran them with elevated privileges. Look at them, right? So now we can run this as normal user, okay? So we want to make a directory at home. So if for any reason you had switched routes to run those commands, you need to switch back home, right? To the home of Ubuntu to run these commands. Okay, so now I copy this, right? It has even been given to us what we need to do. You can see, make dir, right? So pasting that, that's the first one. Okay, so the next one is what? Tells us what to do. I copy this, that's the next command. I paste that. What else? This, right? All those commands in the script there, right? I'm pasting, right? So what else? So if I'm running as a root user, I should run as this, but no, I didn't. So should now deploy a pod network to the cluster, right? Then you can join any number of worker nodes by running the following on each as root, okay? So we can run on each as root. Okay, so we can run on each as root, okay? So we can run on each as root. Okay, so let's go back to the script. Okay, so we've done 1, 2, 3. Okay, so let's look at this to verify whether kubectl is working or not. Let's run this command. Okay, so you know we've installed kubectl. So let's run that command. Yeah, so on the manager node. So okay, yeah, we see that we have this running, but this and this are pending. Okay, so what should we do next? Okay, what we can do is to from the foregoing, all but core DNS pods should be running. To resolve this, install a WIF pod network. So let's install a WIF pod network, right? So only core DNS are not running as it is now. So let's see what will happen. So core DNS, you can see these ones are pending. So let's run this. Okay, let's run this and see what we get. So let's try to run that command again and see what we'll have. Okay, it's still loading. Let's run it again. Still shows pending. Okay, so it's now running. You now see 2 of 2. And if you look at this, you see that these ones, that the core DNS that were not running before are now running. Can you see? So the core DNS pods are now running. So what else can we do? Let's go back to the script and look at the steps that we have outstanding, okay? So we can check the nodes that we currently have, right? Remember the nodes, EC2 instances, and let's see what we'll get, okay? Let's check nodes. Let's check nodes. kubectl get nodes, right? How many nodes do we see? We only see the control plane, but we have 2 other nodes, right? Why don't we see them? Because they've not been connected. Although we've installed all the required applications on them, but we've actually not connected them into the cluster, right? We have them as standalone wherever they are, right? We've set them up, but we've not connected them, right? So what do we need to do at the moment? So let's go back to the script. So everything is highlighted here. So what we now need to do, is to come here to get token, right? Although the token was already given earlier, but we can always get it instead of tracing back, right? So we can copy this, okay? So once we copy that, we come here and we paste that here, still on the worker node, right? So we get this node, right? You see this node that we've got? We copy it, right? And we take it to each of the worker nodes and use, let's look at the script. Let's follow direction here. So to add worker nodes, so these are the next steps, right? We've generated this, we've got the token. To add worker nodes to the manager node, copy the token, right, from the manager node and execute them using elevated privilege in all worker nodes, right? So we'll come here to each of the worker nodes and do something, right? And try to put our sudo before it, right? Sudo. So we run this, okay? Starting the kubelet, whatever. Let's go to the next one and do the same. Okay, so let's take this back. Sudo. So let's see what we have here. You should say, okay, this node has joined the cluster, right? So let's see what we have here. Is it done yet? Still waiting. Okay, so this node has joined the cluster. So we have 3 nodes in the cluster. So we have the manager node and the worker nodes. The manager node is the controller plane, right? Remember our diagram here? Remember our diagram? This is the controller plane, right? The controller plane. It has the controller manager, the cloud controller manager, it has the etcd, it has the API, it has the scheduler, right? So that is it. So we've been able to form a cluster. So can we confirm whether this cluster has actually been formed? Please take note that all the commands you'll be running will be run on the manager node. Okay, we'll be running them on the manager node, all the commands that we'll be running. So let's just confirm. Remember, we ran a command earlier, kubectl get nodes, and we only saw one node, right? That's just the control plane. So let's run it again and see what we'll get. You see, we now have these other nodes, right? That they are ready. Can you see them? We have these other nodes. They are ready. They are ready for work. Okay, so let's see if there's anything we have on the script that we've not touched. Okay, so let's see. We've got nodes, we've checked. Okay, so what else have we not done? Let's try to deploy a sample application, right? Remember, kubectl commands have to be executed in the manager node, okay? So what do we need to do? We need to come and run this command, the sample. That's one we looked at earlier, when we were trying to explain deployment. So let's run this, okay? So let's run this here. So we can see the pod has been created, okay? So let's see, the pod has been created. What else has happened? So let's see, let's create a service object, okay? In Unix, so let's create a service object by running this, okay? So let's run that to create a service object. So let's run this. Okay, so what else can we do? Let's see what else we have. So we want to get services, right? Remember, we just created a service now, this node port, right? We just created it. So let's use this to get services, to see everything we have. Let's get services, right? We can get services, you can see. This is the one we just created now, node port, Nginx demo, right? So these are the services that we have. So let's run get nodes. You can see those are the nodes that we've created. So what else? Let's see. So there's just a lot to do. So let's take a pause here and meet in the next session while we look at several Kubernetes commands and we can proceed. Thank you. See you in the next session.